A cone tank with an upper radius of 4 meters and a height of 5 meters drains into a cylinder tank with a radius of 4 meters and a height of 5 meters. If the water level in the conical tank drops at a rate of 0.5 meters per minute, at what rate does the water level in the cylinder tank rise when the water level in the conical tank is 3 meters and 1 meter? Since water from the top tank drains into the bottom tank, the volume is decreasing at the same rate as the volume in the bottom tank is increasing. We need to find the derivative of both of the volume equations and then set them equal to each other. First, we'll work on the volume formula for the top tank. Let V sub 1, H sub 1, and R sub 1 be volume, water level, and radius for the top tank. The volume formula then is V sub 1 equals 1/3 pi R sub 1 squared times H sub 1. Before finding the derivative, replace R sub 1 with the relationship using H sub 1 by doing the following. R sub 1 over H sub 1 equals 4/5. Solve for R sub 1 by multiplying H sub 1 on both sides. R sub 1 then equals 4/5 times H sub 1. Now we know what R sub 1 is and can substitute it into the formula like so. V sub 1 equals 1/3 pi times 4/5 H sub 1 squared times H sub 1. To simplify, we can first enter in the power of 2. V sub 1 equals 1/3 pi. 4 squared is 16. 5 squared is 25. Times H sub 1 squared times H sub 1. To further simplify, multiply the two fractions together and multiply the two H sub 1's together. V sub 1 equals 16/75 pi times H sub 1 to the third power. We can now take the derivative of both sides with respect to t. The derivative of V sub 1 with respect to t equals 16/75 pi 3 H sub 1 squared times the derivative of H with respect to t. To simplify, we divide the 3 into 75. The derivative of V sub 1 with respect to t equals 16/25 pi H sub 1 squared times the derivative of H with respect to t. We were given the derivative of H with respect to t. We were told the water level in the top tank drops at a rate of 0.5 meters per minute. So we can plug in negative 0.5 into the derivative. The derivative of v sub 1 with respect to t equals 16 over 25 pi times h sub 1 squared times negative 0.5. To simplify, we can multiply negative 0.5 with the fraction and get the derivative of v sub 1 with respect to t equals negative 8 over 25 pi h sub 1 squared. Okay. Now we can work on the bottom tank. Let v sub 2 and h sub 2 be volume and water level of the cylinder tank. The volume formula is then v sub 2 equals pi r squared times h sub 2. Be good. Since the radius is unchanging, it will stay a constant. We were given that the radius is 4. So r squared equals 4 squared, which is 16. We can plug in 16 into the formula and get v sub 2 equals 16 pi times h sub 2. We can now take the derivative of both sides with respect to t. The derivative of v sub 2 with respect to t equals 16 pi times the derivative of h sub 2 with respect to t. We have found the derivatives for both of the volume formulas. We can now set these derivatives equal to each other. The derivative of v sub 2 with respect to t equals the derivative of v sub 1 with respect to t. The derivative of v sub 1 has to be negative because the rate of change for the conical tank is decreasing. So, 16 pi times the derivative of h sub 2 with respect to t equals negative 8 over 25 pi times h sub 1 squared. Continuing on, these negatives cancel each other, so we can get rid of those. Since we are asked for the rate of change for the increasing water level in the cylinder tank, we need to solve for the derivative of h sub 2 with respect to t. To do that, we will divide 16 pi on both sides and get the derivative of h sub 2 with respect to t equals 8/25 pi h sub 1 squared over 16 pi. To simplify, the pi's cancel out. Dividing 8/25 by 16 reduces to 1/5, and you are left with the derivative of h sub 2 with respect to t equals 1/50 times h sub 1 squared. Now that we have the final equation needed, we can plug in whatever water level of the conical tank and get the rate of change for the rising water level in the cylinder tank. For when the conical tank's water level is 3 meters, h sub 1 equals 3, we can plug it in. The derivative of h sub 2 with respect to t equals 1 over 50 times 3 squared equals 9 over 50, which equals 0.18 meters per minute. In words, the water level in the cylinder tank rises at 0.18 meters per minute. For when the conical tank's water level is 1 meter, h sub 1 equals 1. The derivative of h sub 2 with respect to t equals 1 over 50 times 1 squared equals 1 over 50, which equals 0.02 meters per minute. In words, the water level of the cylinder tank rises at 0.02 meters per minute.